Welcome to Elementary Algebra, Chapter 17. The author is Harold Jacobs. I'm your presenter, Molly Crocker, and yes, this material is copyrighted. Chapter 17, Lesson 2, Arithmetic Sequences. To begin with, we're going to talk about finding the sum of terms for an arithmetic sequence. Did you read the lesson? The gist of the lesson is the sum of terms in a sequence can be found by turning it into a rectangle. Let me show you an example that's not in the book. Here I have sorted a set of double six dominoes into a stair-step period. Dominoes are those tiles that we like to connect because the ends match. And a double six domino set, the domino with the most number of dots has 6 dots on each end of that domino. That's the one that's at the top in this pyramid. How many tiles are there in this set without counting all of the tiles? Now I know it wouldn't take you long to count all the tiles. Since there are 7 rows, I could not split the number of rows in half, as half of 7 is 3.5. But I took off the top 3 rows, and now I turn the top group and line it up where I'd like it and fit it into the bottom group, and now I see that this rectangle is 7 tiles by 4 rows, so 28 tiles in all. Let's go back to that first pyramid. Remember, the question was about adding the number of tiles, not the spots on the tiles. So I could have put these tiles in any order I wanted. That idea of adding up the spots on the tiles is another sequence, and I'll do that in a few slides just for your viewing pleasure. I did put these tiles in some kind of order. Can you see it? Well, let's talk about that formula for adding up all the terms of an arithmetic sequence. How many tiles are there in the bottom row? 7. How many tiles in the top row? Just 1. The sum of the first and the last terms is 8. I'm filling in my formula. T sub 1 plus T sub n is 7 plus 1, or 8. How many rows are there? 7. That's what our n is in our formula. 8 times 7 is 56. Then divide it all by 2, which is 28. Now, this is where I'm telling you to just sit back and watch while I build this slide. Let's talk about the dots on the tiles. This is another sequence. In the top row, there is just 1 tile, and the sum of its dots is 12. The sum of the dots in the next row is 21. 5 and 6 is 11, and then 2 more 5s is 10, so that's 21. Here's the rest of the sums of the dots on the tiles in the row. Do you see a pattern? Do you recognize what this pattern is from the table? It's actually quadratic. Here's the vertex form of the equation where the x's would match up, well, in some form. The x's would match up with the y's and give you these numbers. Here's the equation that generates the terms. You likely wouldn't have guessed that. And it isn't either arithmetic or geometric. It falls in the category of other. Onward. Here are the steps for finding the sum of the terms in an arithmetic sequence. The sum of the terms in a sequence is the sum of the first term added to the nth term, which is the last term, and then that sum multiplied to the number of terms, and then divided by 2. Pause here and make some notes. Now, how do we find the nth term of an arithmetic sequence? This diagram is in your book. Do you see it? Since we keep adding on a difference to the first term, then the formula for the nth term is the sum of the first term and n minus 1 differences. Here the letter D stands for the difference, And if I want to find the 10th term, then I would start with the first term and add on 9 differences. 10 is n, 9 is n minus 1, 10 minus 1. Make sure these two formulas are in your notes. The upper is the sum of a group of terms. We don't have to add up all the terms in the sequence. The sequence could go on forever. The lower is how to find a particular term. Now let's try some problems. Here's an arithmetic sequence. Can you tell from the first three terms that it's an arithmetic sequence? The difference between the terms is 4. Let's find the sum of the first 6 terms. So first of all, we need to know what the 6th term is. Well, what's the difference between the terms again? 4. So to the first term, which is 10, we will add 6 minus 1, or 5 differences of 4. That would be 20. So the 6th term is 30. Now, to find the sum of the first 6 terms, we add the first term to the last term, multiply by 6, which is the number of terms we are adding together, and then divide by 2. All that yields is 120. Let's talk about the homework. Homework problem number 3. I love this problem. It illustrates how an average works. Here's the steps. First of all, average all the numbers, add them all together and divide by the number of numbers. Then subtract the average hand span from each of the measurements. Collect these differences and then add them together. And then what do you conclude about the sum of the differences between the average and the numbers averaged? Pause the video here if you need to follow these steps out for this problem. And I'm not going to give away the last question. When we are asked to graph for this chapter, I said we are going to use bar graphs. In 4a, the bars all extend upwards from the x-axis, but it's possible to have them both above and below, as in problem 4e. So let's go there. Graph paper is nice for this homework, which you can also just simply sketch. I will show you both. First, here's the sequence for 4e. Now, you're going to see my graph, and then I'm going to overwrite how I did this. So, first of all, here's my almost finished graph. The first thing I did was draw a line for the y-axis. Then, I put the x-axis near the middle. And then, I drew bars for each term, 7 and 4 and 1 and -2 and -5. There's my bars. And then I fill in between the bars and the x-axis. I'm not going to do that on the first grid. I'm going to show you my finished product. This is your math homework. It doesn't have to be super pretty. Here's what it would look like if I were just sketching. I did this on the back side of some scrap paper that had something printed on the other side. I didn't even use graph paper. The numbers on my sketch say more than the accuracy of my sketch. My picture isn't very accurate, but the numbers say what I intended to mean. (7.2) Let's summarize. T sub 1 is the first term of a sequence. T sub n is the nth term of a sequence. To find the nth term of an arithmetic sequence, first determine the difference between successive terms and add on one less difference than n to the first term. The formula for the nth term of an arithmetic sequence is the nth term is found by t sub 1, the first term, plus n minus 1, that's the number of terms, take away 1, times the number of terms minus 1 differences. T sub n equals t sub 1 plus the group n minus 1 multiplied to d. To find the sum of n terms of an arithmetic sequence, add the first term and the last term. Multiply the number of terms we are adding together, and then divide by 2. Add the first term, t sub 1, to the last term, t sub n. Multiply that sum to the number of differences, that's n. Divide that whole product by 2. That's all for now.